So welcome to this chapter of wave optics. Now wave optics deals with the wave nature of light. We know light has both dual nature. It has particle nature as well as wave nature. So basically this deals with the wave nature of light. Wave nature of light. Now how can we understand this wave nature? Now because light is a wave, but the formation of this wave is not visible to our naked eyes. So we have to take different examples in order to understand wave and all its concept. Now say suppose, as we have discussed in our class 11 chapters of wave, wave is sometimes is a disturbance in a medium, but sometimes it is a transfer of energy. Now let's take an example over here. So say suppose this is a uh, say suppose this is a lake, and on that lake I give a small disturbance. This is my lake, and on this lake I disturb the medium by throwing a stone over here. So as soon as I have transferred energy, you will see the wave, the first wave that is being formed. And because of this wave, it moves up, and it in return it creates another wave that is over here. So this in turn creates another wave. So in a way, this particular wave is creating this wave is creating this wave. This may seem to us. So with this understanding that one wave creates another wave which is responsible for creating another wave, and this forms a chain. This forms a chain. So this particular chain and this particular concept, if we try to understand, we come across a term that is wave front. This is wave front. Wave front. Now what is wave front? Wave front are a surface. Wave front are a surface. Now it is a surface containing, what is this? It is containing points. Containing points. Now this is a wave front. This whole is a wave front. Now this is a surface which contains all the points that is being affected in the same way. All these points are affected in the same way by a wave. Because of this wave, all these points are affected in the same way in a given amount of time. And this containing points affected, let me complete the whole definition. Affected in the, please keep in mind, in the same way. In the same way by a wave. By a wave at a given time. At a given time. So at a time t equals to t naught, all of this surface will be affected equally, and all of this will be in equal phase. Equal phase. So after this particular definition, we come to a conclusion as to defining what is wave front. We can define wave front that is being created by the primary wave, and this can be regarded as a secondary wave, and this wave in turn will create another wave. So if you look at this wave, this is a wave front because it has the same phase and it is affected equally by this energy, or you can say by this wave. So by understanding wave front, now we are in a position to define what is Huygen's principle. So let's have a look at what is Huygen's principle and what does he say about wavefront in our next slide. So Huygen's principle, or Huygen's principle, as you want to pronounce it, because it has a bit of a different pronunciation in different parts of the world. So Huygen's principle states that at every point on a wavefront, at every point on a wavefront, on a wavefront, at every point, or every point, not at, let's say every point on a wavefront is a source of wavelength, is a source of wavelets, and this wavelets spread out in the forward direction, spread out in the forward direction, at the same speed as the source wave, forward direction at the same speed as the source wave, as the source wave. And this new wavefront and this new wavefront, sorry, this is wavefront, and this new wavefront is a line tangent to all the wavelengths. It's a line tangent to all the wavelets. So we had understood what it was in a previous slide. We had understood what it was physically. Now in a statement, it was given by Huygen's principle, and it is saying that every point in a wavefront is a source of wavelets, and this wavelets, say suppose this is your one source, and this point is a source of another such wavelets. Because of this, it's a source of another such wavelets, and this wavelet spread out in the forward direction. Because this spread out always spreads out in the forward direction. You will never see something coming like this. No, it is absolutely wrong. Forward direction at the same speed as the source wave. So at what speed is this traveling? It creates another wavelets. Because of this source, it is creating another wavelets, and all of these wavelets are moving at the same speed as of this. So the new wavefront is a line tangent to all the wavefront. So the new wavefront is a line that is tangent. So if you look at here, if you draw this, it is tangent. So in a way, we can see that this is a line tangent to all the wavelets. This is a line that is tangent to all the wavelets. So this was what Huygen's principles tells us about wavelets and wavefront.